Yes? Okay, now we have about 40 minutes to tell you what's new in BricsCAD Mechanical V20. 40 minutes, it's so short because our development team worked hard for 1 year. They implemented a lot of new features. Of course, it's impossible to present everything they develop in 40 minutes. That's why in this session, we'll just briefly highlight the most spectacular new features, but everybody who really wants to get a more complete review and also to learn how to use these features in practical workflows is invited to attend our technical training session this afternoon. It will take place at 4 p.m. in a different room. Please don't mix with BIM training. And there we'll also be able to answer your questions. And now, before we start our live demo, let me give you just one slide, one single slide, but it's important to explain what BricsCAD Mechanical is. This is a new product. It was put on the market just 1 year ago. It replaced a product previously called BricsCAD Sheet Metal, but this is not just about sheet metal. We consider BricsCAD Mechanical as a combination of some core toolset of BricsCAD plus assembly design and sheet metal. Speaking about core toolsets which are highly requested by mechanical engineers, first of all, I'd like to mention 3D direct modeling. This is not just the possibility to create 3D solids using extrude or revolve or sweep command, and not only to modify them using the possibility to move and rotate their faces, edges, and pushing and pulling them, but also quite sophisticated tools, for example, to copy a feature like a hole or pocket from one 3D solid to another one, or to apply a powerful deformable modeling toolset. Our direct modeling is unique in that sense that it doesn't matter what CAD was used to create this geometry. We can equally edit native and imported geometry. And the same is true for our 3D parametric modeling. It is history-free, which means that you can create parametric model independently on design history of your geometry. Using a powerful tool set of 3D constraints, associative arrays, parametric components, and component-based features, you can add complex parametric behavior to your model, and you can link parameters using expressions, design tables. And in V20, we extended this toolset with new features, such as the possibility to suppress particular entities in your drawing depending on the value of particular expression, the possibility to control the movement of an entity along a path, and also the possibility to use a reference constraint to take a particular measurement in your model and use it as input for other parametric features. Of course, every mechanical engineer needs to generate drawing views from 3D model, and we use this. Our users use this toolset very intensively. But they claim that it can take some minutes to generate precise drawing views for large assemblies that contain thousands of parts. That's true. That's because our drawing views are precise. Every silhouette edge is represented as analytical 2D curve, and it takes some time to recognize that a particular silhouette, for example, is an arc. But answering this request, in V20 we implemented draft quality drawing views, which are generated in seconds. You can immediately put them on layout and start to annotate, and you can switch to precise drawing view at any moment later. Another new feature of this drawing views toolset is the possibility to correctly represent threaded bolts, threaded nuts, threaded holes in your drawing according to international drafting standard. Our assembly design toolset allows you to create hierarchies of your parts using assembly, sub-assemblies, and you can combine both top-down and bottom-up approach. You can form components from existing geometry, or you can insert existing components, including several hundreds of standard parts. In V20, we added a couple of new families to parametric standard part library. These are pipe flanges and threaded holes. We also support a rich library of physical materials. You can assign different materials to different parts in your assembly, and you can correctly compute the total weight of your product. You can detect center of gravity, and you can, of course, generate bill of materials to manufacture your product. And bill of material toolset was completely redesigned in V20. Now we have a dedicated bill of material panel, which is your single editor for bill of materials tables. In what you see is what you get manner. When you create technical drawings for your assemblies, it is unavoidable to use exploited views when every part is represented disassembled. In V20, we implemented fully automatic multi-axis exploded views with the possibility to add automatically trailing lines to trace the trajectories of parts from their initial position in the assembly to the position in exploded view. Our sheet metal toolset was already quite mature. We supported traditional design flange by flange. We also support the possibility to convert any existing geometry to a valid sheet metal part by recognizing particular features such as flanges or bends. We implement a unique technology for lofted bend, which allows you to create ruled surface between two arbitrary 3D curves and automatically unfold it. You can edit unfolded representation of your sheet metal part to fix possible material conflict, and in folded view you will get immediate associative feedback on it. And you can process large assemblies in just one click and automatically generate all the XF files needed to a CAM system to manufacture all sheet metal parts. In V20, this toolset was extended with several new features, such as HAM to model sheet metal hemming process, tabs and slot to connect to flanges, the possibility to create a flange from a 2D contour and automatically connect it to existing part, and some other features which will be presented later. Please remember that in contrast to some other product which also uses mechanical in its name, our product is 3D. It's not about 2D. It means that you can create complex shape and you can use it to check collisions in your assembly. You can use it to model kinematics. You can pass this model for stress analysis to engineering design software, to computer-aided manufacturing software to generate NC code and so on, something which is not possible in 2D. But of course, if you need 2D drawings, they can always be generated from this 3D model, and this documentation, this 2D documentation is automatically updated when your 3D model is changed. And now, it's already not a big surprise, but anyway, this is the model we prepared this year for our demo. This is escalator. It looks like a beam object, and in fact, it is a beam object. But inside this model, we did a lot of parts, a lot of mechanical parts. We did steps, main drive shaft, engine, chains, frame, and we made this model fully parametric. It means that you can change, for example, its height, because the escalator, of course, should be adopted to every particular building and independent on the distance between two stages, two floors. You can see how parts are adopted to the change of this height. It's quite sophisticated parametric behavior. For example, for this support, when we change the height of the escalator, you can see that not only the length of particular components is changed, but also their geometric position. And of course, this is escalator, it should move, right? And it moves. It moves, and of course, to make it moving, it's not enough just to animate this step movement. What is also needed is to model the complete mechanism which is needed to make this movement possible. So we see that there is an engine, there is a main drive shaft which is rotated, there are some chains, some gears which put this rotation to the steps. And we can check that, yes, everything is designed according to our intent. There is no collision between parts when they are moved. And so we can ensure that our product is correct before manufacture it. By the way, this movie was recorded in BricsCAD with no use of any other software. This was possible thanks to the new animation editor. Let me better show you one more short movie with the same escalator, which demonstrates the capabilities of this animation editor. It implements multi-parametric simultaneous animation of several entities, and you can create quite complex scenarios, and you can replay them in real time. You can record videos, everything. So everybody who is interested in to know more about this editor is invited to attend our training session this afternoon, because in this session, unfortunately, we don't have enough time to present it. And now let us switch to the live demo finally. My colleague Ilya Tatarnikov will help me. In fact, he will do the job, I will just comment. So this is our escalator opened in BricsCAD. You can see its geometry in graphical area, and also you can see the product structure on the left of the screen in mechanical browser. Because we want to focus on this model as a mechanical model, we first will hide one side covering to always control what's inside. And let's start with demonstrating the most interesting mechanical feature in BricsCAD V20. This is bill of material panel. Previously, bill of materials were represented as tables in your drawing, which you can insert either in paper space or in model space. It still exists, this possibility, but you can start your designing your bill of material with this panel. It's interactive. It allows you to configure your bill of material. It allows you to edit, to insert in your document, and so on. But what is interesting, one of the new additions, if you scroll down, we'll see that there is a footer row which can be used to see, for example, the total quantity of parts in your assembly. We see that almost 4,000 parts here, and the total weight, which is almost 10 tons. And because our model is parametric, we can change the height of this escalator. Let's do that. Remember, it's 4,000 parts. You can measure what time is needed to go from 6 meters to 10 meters. It's just a matter of a couple of seconds, not more. And when the height is changed, we can regenerate bill of material. It takes slightly bit more time because the information is taken from the full database again. And while it is regenerated, let me briefly describe the new features of this new panel. First of all, this is the possibility to add formulas, not only in a footer row, but in any column, and also the possibility to sort and filter out particular components. And now, when it is updated, we can check that for example, for 10 meters height escalator, the total number of parts is over 5,000, and the weight is increased up to 13 tons. By the way, this table can be used not only as information about your model, you can use it for navigation. For example, if you double-click on a particular row, you can see, yes, you can zoom to a particular component and see where it is located in your assembly. Okay, you probably noted that when we increased the height from 6 to 10 meters, an additional supporting structure appeared, represented as blue column. This was possible thanks to the new feature which is called suppress feature. Suppress feature allows you to temporarily suppress a group of entities depending on a particular condition. In that case, this condition is expressed as a sign between the actual height of the escalator and the minimal height without column. When the actual height is less, the column is automatically suppressed, which means it is removed from your assembly. If the height is greater, it appears. And this feature allows us and every user of BricsCAD also to model level of details of assembly. We implemented it in this assembly as a parameter which is called simplified, which can be set, for example, to 1. And immediately after that, we get a simplified representation of our escalator. If we show this side covering again, you will see no difference. No difference in visual feedback, but the great difference in performance, because less number of parts is used in this level of detail, in simplified level of detail. And also, you don't need to disclosure the content of your assembly. You can use it as if to insert it in a beam building. And now, I still have few minutes to show you the new features in technical drawing generation. We will not generate the full technical drawing for this escalator. We'll take this main draft shaft assembly. If I need to create a manual to maintain, for example, this particular subassembly, it is often required to create a disassembled representation, so-called exploded view, and previously we demonstrated it to you 1 year ago. It was possible, and it is still possible, to create automatic exploded view in one particular direction, taking into account possible physical collision between parts. So it models a real disassembly sequence, but only in one direction. And for example, in that case, we see that these bolts, they were not disassembled because it's not possible to move them in the same direction without collision. And the same can be said about these gears. So that's why we decided to implement fully automatic exploded view. Just in one click, you can get all parts disassembled in all possible directions, of course taking into account also possible collision between them. Now you see that these bolts are disassembled. And as other exploded views, this view can be animated, which can be useful if you want to create, for example, a technical documentation for your product as a movie, as kind of an animated instruction of how to disassemble or assemble your part. So this movie gives you the idea how to do that in dynamics, but if you have a static picture printed on a paper, it's hard to realize how it was achieved from the assembled view. That's why we implemented what is called trailing lines. You can automatically add to any view automatic or manual trailing lines, which represent trajectories of parts from their initial position in the assembly to the position in exploded view. And so you can easily realize how to assemble this product back. And of course, you can put this exploded view in your layout to create technical documentation. And you can choose a special view. You can use a standard view-based command to do that. Just select a special view, select the proper scale, which is needed for your view, and put it. And you can now annotate this view. To annotate, you first have to generate a bill of materials table. By the way, if you don't want these trailing lines to be presented in exploded view, you can always switch the corresponding layer off. And now we can add balloons, which represents position of particular parts in our bill of material table. Okay, we can specify in that case that we only want to annotate unique parts, not all parts, and place these balloons. And just one more second to show you another example. Let's take a particular subassembly of these two gears and create very simple view. Let's create a view on this assembly from bottom, because from bottom we can see that there are bolts, and these bolts they have threads, and these threads, if you generate this view, these threads are represented as this arc. This is a kind of standard for drafting to represent thread. And if we create a section view from this bottom view, then we can see that these bolts, they won't be sectioned, again, because this is a mechanical standard to do not section standard part, but we can see this thread again here. And one more new feature, a very small improvement, but very useful. You can easily align particular views. For example, you can specify that a particular segment on your view should be vertical. Okay, this was just a very brief highlight. And again, everybody, please don't hesitate to visit our training at 4 p.m. in a different room. And now I'm glad to invite my colleague, Christian Lecomte, who will continue with new sheet metal feature. Thank you for your attention.
Thank you, Dimitri. Yes, I'm Christian Lecomte. I'm the French guy in the troupe. But I am aware of this handicap, and I will try to make my best to be comprehensible. Let's go. I suppose this is okay. I will speak about sheet metal with the help of my colleague Ilya Tartarnikov. So we will use this device, which is at the end of the handrail and on the floor at the entry of the escalator. For that, we will design from scratch. We'll design from scratch in using the existing part of the assembly. We will do that in place. And you will be able to appreciate the power of direct modeling. So the result we will obtain is this model. I insist, this model is just a solid, just a shelled solid. And we are free to decide to make this part in plastic, in metal, or whatever. If you don't believe me, in the airport coming to the conference, I have seen some example of this part in plastic. And you see that it is live because there is still a paper handkerchief on the floor. So, but we decide to make it in sheet metal. And we can decide because in our philosophy, we start from the intent. In a usual CAD system, to create from scratch a sheet metal part, you have to start from and to make it with sheet metal functions. And it limits drastically your creativity because you are driven by the functions. And the functions are limited, and of course, you are limited. In our philosophy, we create, you have seen, we have created this model, and then we decide to convert in manufacturable sheet metal parts. So this is very important. We start from the design intent and not from the way to produce. And we will get this result, and of course, we will unfold. And I will show you some additional features. No, we have got this result for one part. But what about an assembly that we receive from another designer using another CAD system? We will import this assembly, this tone style. We need this anywhere in the station, and this assembly was done by another CAD system, and it's already designed in sheet metal. And so we will see how to immediately, with our batch processing, we will immediately get all the documents, all the unfoldings, sort the part between mechanical parts, sheet metal parts, and so on. And I think we will have a surprise, but suspense. And you will agree with me after this demo that we are alone in the highest classroom. So let's go for the demo. So first, we will replace this not beautiful device, and we will create, starting from the outside profile. We just first make an extrusion and then create a chamfer that we will change the angle. Now I suppose Ilya will isolate the part to be free to work on it. Okay. Then we will create a fillet here, and yes, change the angle, be accurate, make a fillet, and then create a profile on this plane, and we will use this profile to cut the model. It's just for aesthetical reason. And it's important to notice that we got two cylinders crossing themselves. You will see that it's important for the next step. Then we'll create the necessary holes in this in this model. Then we will shell to get something with the same thickness everywhere. That it's for the rail, we have some holes to create. Then a square with fillets that we will put in the right position. Okay, we got this model, and we decide to make it in sheet metal. This is our choice, a decision. So first, we will convert, and we will repair in order to get all the edges at 90 degrees. It is important for sheet metal. That now, we will create first one bend here, and then we will follow a line to make a sort of path, a junction, and you see that despite we have a very complex curve, we get a perfect junction. This is unique. Now, we will create the other bends, necessary bends, and for this side, just in clicking on this side, we got all the junction because it's flat side. And this is now unfoldable. You have seen as it is quick for this complex part to get the unfolding. But just come back to the part now, in order to avoid hard. No. Now, yes, we will create some flanges, and we will use the propagate function that we have seen yesterday. We have used the propagate function for some, so you see, and then you have just to pull, and we got 5 new flanges instead of 1 by 1. Then we have to we will create now hem functions to avoid sharp edges, and you see that the hem function follow the geometry. There is no collision. This is not just a simple pulling. So now we have to give enough place for the rail. So we just, okay. And this part is finished. But we will use this hole to create the light side. You will see as it is easy. So first, 2 fillets to make something round, and we will incline the top of this part a little bit back. And then we will shell to create sheet metal parts. But of course, we have to. We will create this circle to create a hole. Okay, and then we will convert. Okay, just creating this band. Now we will create all the junction in one time. Okay, the part is done, 3 parts. But we will now see this is a junction, and we will use this junction to create now a new feature, which is tab and slot. In this case, we create just one to guarantee the positioning of the light side. We will create 2 there, but we have another possibility. We will choose in this to make an array of tabs, and then to create 3 in this case. But if you are interested, this afternoon we will make it show more deeply those functions, and then we can unfold all the parts. And we have got this result in several minutes. And we have all, and you see the tabs on the part. No. Now let's import this the turnstile. There is 3 elements. We will make the demo with 1 element. This is an assembly which is already in sheet metal. It comes from another CAD system. It is already in sheet metal. And we will use our function to, in just 1 click, get all the unfoldings and sort the parts. So the system creates automatically the necessary folders, sort the part in sheet metal and not sheet metal, and get and obtain the unfolding for all the sheet metal parts. It's not very long. So now we can open the result, the report. You see there the parts sorted, the unfolding that can be used for CAM system, and we have the non-sheet metal parts, and we have a poor sheet metal. This is a surprise. The poor sheet metal, it means that it can be sheet metal, but there is a problem. The part cannot be unfolded or something like that. So we will open it to see what happened. And you see that because with another system it is impossible to unfold, they keep that in a shelled solid. With BricsCAD, we will convert it now. We will apply all the bands, all the necessary bands. You will see that all the bands are automatically created in place. And then we will select all the paths to create automatically all the junctions. Yes, you see? All the junctions are created, and now you can unfold. This is just impossible with any other CAD. So, I think it's the end. So thank you.
Wow.